Hello maths fans, welcome to the second part of the GCSE maths exam video series. I'm once again joined by Ben Sparks. Again, hopefully you now recognise him from all of those number file videos featuring Ben that you've since watched from the first of our exam videos. As mentioned before, we have both completed the GCSE maths higher exam, we've exchanged papers, and we are now going to mark each other's work. Or in fact, we have already marked each other's work, is what I should say, and we are now about to exchange thoughts, comments, have a bit of a markers meeting, let's say, to discuss the questions and of course reveal who got the highest mark. Though it's definitely not a competition, as we both keep stressing.
Definitely not a competition, because that would be against the spirit of an exam, wouldn't it? Wait.
It would indeed. This is why we wanted to record this follow-up marking video, in fact, to emphasise the collaborative nature of the way that we do maths.
Exams force competitive behaviour, I think, a little bit, where both of us, actually what we're all about is learning maths and doing maths and teaching maths, and the competitive nature of exams sometimes kind of gets in the way of that. However,
agreed.
When an exam happens, it's very hard not to get a tiny bit competitive. I'm sure you do.
Yeah. No, I'm mildly terrified about how this is going to go. I'm not feeling particularly confident. And actually, I'm intrigued to ask you, Ben, how did you find it? How do you think, not necessarily how do you think you've done, but, give me your thoughts on having sat the GCSE higher maths exam.
It was okay. I was worried I was going to find bits of it like way beyond my memory of what I should be able to do, but it was okay. So that was my sort of overriding reaction. But there were bits that stretched me more than I expected, and there were bits I found more tedious than I expected. Maybe I expected some of it to be kind of dull, and some of it is dull. And there are bits that I know I messed up. Like in hindsight, I'm thinking I was probably panicking, and I'm pretty sure I got some calculations wrong. But it's very hard to, I deliberately haven't gone back to mark my own script because I've obviously let the professional do that. Thanks, Tom. But I think I did all right. I don't think I would have failed. I'll put it that way. Don't think so.
You certainly have not failed. I will confirm that right now. I don't know what a fail mark is, like below 20% or something. Or no, you've done very well. I would like to think that both of us were expecting pretty high marks. Like we should. Right?
So what were you feeling? Did you feel like it was an easy experience, or was it harder than you expected?
No. It definitely was an easy experience, but I guess I have a little bit more practice having done the maths A-level exam and the further maths A-level exam
recently,
in this same context, all being recorded and, throwing out there to the internet me doing a maths exam.
It's daunting.
So I kind of knew a little bit about what to expect in that sense. The thing that really got me, and I've actually already mentioned this to a few people who've been asking about how this all went, is there's a lot of knowledge in GCSE maths that it feels like you kind of learn it just for your GCSE maths exam.
I agree.
So what I found was with the A-level exams, everything there, even though I hadn't used it for over 10 years, like specifically in an A-level context, it was all things that I have since gone on to use at university or I use when I'm teaching every week.
Yeah.
Whereas with some of the GCSE stuff, it was like, I remember this is a thing, but I quite literally, I learnt it for my GCSE maths exam and I have not used it in the 15 years since. So
in particular,
that's what I found.
For me, techniques that need maybe, if you're going to do it for real, which we've both probably done, you would never do by hand. Like it's the sort of thing that you only ever do it on paper once, and that's for the GCSE exam. And I understand why you have to teach it. If you're going to get a computer to do something, you need to know how it's going to do it. But there are things I would never want to do by hand ever again, mostly involving spreadsheet style things.
The graph sketching questions, like accurate graphs. I understand the value of it, but I haven't drawn an accurate graph in literally 10 years.
I'm trying not to comment on whether you lost marks for that or not.
You used this square grid on the paper, whereas I had to redraw it. I felt I was at such a disadvantage.
I read the instructions, which says complete the exam on the exam paper. I'm sorry if you missed that line, but I had to mark blank paper with your rubbishy sketches. But we'll get to that, right? We'll get.
We will. On that note, in fact, shall we reveal the marks?
I think we should. Let's get this out of the way.
I'm really quite nervous and excited at the same time about this. I'm just going to say, I'll allow you to add your own comment in a second. I'm pretty sure I know what I've got. Maybe I'll write what I think I've got in small letters on this page, right next to your mark. And maybe you can do the same if you like. Do you have an idea in your head? So I actually
Yeah,
think I know what mark I've got.
I've deliberately tried to not count up, but yeah, you're right. I have a pretty good. Are you going to write in terms of number of marks? It was out of 80, wasn't it? This paper.
It was out of 80 indeed, yeah. So these are going to be the marks out of 80. Yours is going to be giant, and then I've written mine really small in the corner.
Yeah,
just so
that
people know I'm not cheating when I'm predicting what I think I got.
You've put me on the spot, though, because I haven't thought about this.
It's only because as I was marking your paper, I was spotting where we agreed, disagreed, and of course, seeing the mark scheme at the same time was kind of figuring out what was going on. So
okay, I've put my prediction in the top right of my little piece of paper, and yours is large with appropriate comments.
Right.
Are we going to hold it up and turn around? Yeah, is that what we're going to do?
I'm gonna hold it up, and we're gonna like reveal to each other at the exact same time, and hopefully catch our reactions. Okay.
You count it.
I'm already gonna say in advance, congratulations, Ben. 3, 2,
Not a
1,
competition.
go. Oh, what? You absolutely smashed me.
Right, so
78 for
my
Ben.
exposure is possibly an issue here, but I predicted 75 plus, so yes, okay. I gave you 73.
I thought I'd get 75. It's tiny and in the corner, but I wrote 75 as my prediction.
Well, the moderators' meeting hasn't happened yet, so everything yet may change, right?
I can't. If it is actually 73, I'm very disappointed. I'm not happy with 73.
Well, I mean, if you turn it into a percentage, right, that's over 90%, and I think in every sort of grade boundary allocation, it's absolutely smashed the top grade, right? It's way above level 9.
Oh, yeah. No, it's just...
As you should
I'm even more interested now to actually have our discussion about where the marks are won and lost, to be honest.
Well, I think both of us having recently marked a script, it's a good reminder how organic the process of marking a paper is. Like, it's not as black and white as we'd all love it to be for exams, right? And there's loads of room for discussion. So if you can talk me into giving you more marks, I'd be happy to hear it.
Well, I think, and I mentioned this when I was marking, I was trying to be generally very generous because I thought the best way for me to do this would be how I would actually mark an exam and how I would mark my students' exams. Even though it's university, I generally try to give as many marks as possible. Of course, that's always my approach to exams. So I felt like that was what I was doing. And something else I mentioned when I was doing the marking was that if you got the right answer and wrote something that to me looked like sensible maths, I was like, yes, and just moved on very quickly.
And I think that's good, actually.
Go through step by step.
I think it even says in the mark scheme that you can kind of do that, particularly if the question doesn't say you must show your working, which some of them do. But if it doesn't say that and the answer's correct and there's nothing obviously wrong above it, it's pretty much in the mark scheme, examiner's advice, give them full marks. For goodness sake, stop wasting your time.
Good, okay. Because that was basically how I was like, has Ben got the right answer? Yes, move on, like kind of approach.
Well, it's interesting that there are questions which change that advice, and they say in bold, you must show your working, and that's when the examiner's advice is a little bit more prescriptive. It says, look, if they haven't shown this step, you cannot give this mark, whether or not they've got the right answer, particularly when the answer is given, which didn't happen very often in this paper, I think, but in lots of other papers. I think in your A-level one, for example, there's lots of show that the answer is, or prove that, and then of course it's more about the method than the answer. Should we start looking at the questions? What should we do?
Yeah, no, I think we should. Let's go from the beginning, see if there's anything interesting to comment on, and maybe point out where each of us have lost marks. I think they're going to be the interesting ones, right? Or maybe where we've used a slightly different method. All right, so question 1 was triangles, similar triangles. I think that was all quite straightforward.
Yeah, 1 mark, and tempting to start using Pythagoras because it was right-angled, but not needed. That was the only interesting thing about that, because they were sucking you into Pythagoras. Not needed, just scale factors.
As soon as I saw that they both had x as the angle, I was like, I know what's going on here.
I do want to comment before we get too far into this that you did choose to do it on plain paper, which I think did put you at a disadvantage in terms of marking, because like circling an answer when it was given a multi-choice, you had to sort of write it. Now, that's not a big disadvantage.
True.
Slowed you down a bit, perhaps, and also, well, we'll talk about the graph sketching, won't we?
Yeah, we will indeed. Right, the next one, work out the value of this.
Question 2,
So what was that? Yeah, you just turned it, I can see here, you've turned it into a single fraction, squared it. I think I did the same thing.
I think you did too. My overriding feeling about this question was that I hate mixed numbers, but I think they should be never used again. In every other circumstance where you write, for example, the answer was 2 and 7/9, but you write 2 next to 7/9, that should be 2 times 7/9 in every other circumstance, algebraically and everything. And so mixed numbers get my goat. I get pretty upset about them.
Okay, the one here that I think I didn't get confused, but I mentioned this was that I wasn't entirely sure whether it wanted the arc length or the perimeter.
Yeah.
Specifically.
I mean, even though it says arc length, Tom. I mean, I do know what you mean. Yeah, but what does that mean? Does it mean the whole shape perimeter? Because it could do. And I think that's the thing you're saying about GCSE, like requires some knowledge which is quite specific and maybe not applicable anytime afterwards. But you need to know what they expect, and that it's rewarding that. Like, but although it does say the arc length of a semicircle, and I guess so I had the same debate, and I eventually decided if they wanted the whole lot, they'd have said perimeter, and that was my only fallback.
Yeah. No, that was yeah.
But you got full marks on that. We both got 6 pi, and that's a relief, I have to say.
Then we've got decimals and fractions, haven't we?
Yeah. So circle the fraction. Again, circle it, and you had to actually go and do it. But we both turned this into a fraction. I think,
wasn't it?
I took a lot longer on this than I should have done. But I was at that stage of panicking of like, I've got to get these easy questions right, or Tom is going to roast me, and he has every right to. But I think we both got the answer. I'm not too worried about it. They're frustrating skills. I understand why they're being checked at GCSE though, but they are sort of skills that we forget to practice because, hey,
true. Very true.
If we use a calculator, no one's going to tell us off.
Question 5, 9.7 times 10 to the minus 4. Yep. Well done, Ben. He knows what standard form is. Another mark. I had a lot of fun with number 5. I had to really rack my brains for what standard form is.
Again, it's another bit of vocab that has a very specific meaning that you've probably not used in a long time. But if you're a physicist, you probably would have done. That's the if you're dealing with irritating units in lots of different things all the time, then that's why standard form ends up being useful. But do you have a definition now? Are you happy having done?
I think it's just is it like you use 2 digits and then it's like something point some. Like 1 digit point another digit, or do you just give 2 digits times 10 to the whatever? Is that how it works?
I think it's got to be a number. This is from the top of my head, and I haven't looked this up recently, but a number between 1 and 10. Yeah. Not inclusively. Or 1 to 9.9 recurring. Hold on. Let's not argue about that one. Times a power of 10, multiplied by a power of 10.
Yeah. I remembered the power of 10. I just wasn't sure exactly how many like numbers you were allowed. So it could be, for example, like 3.14286 times 10 to the something. You can keep going,
you can have as much precision as you like in there.
Gotcha.
But it's got to be in the form of a number between 1 and 10 times a power of 10. I think. Anyway, we both got the right answer, so something went right.
Yeah. It's fine. The next one, so you did this slightly different to me, I can see. So you've taken the 3/4 times whatever tens were left, whereas I multiplied out the top, multiplied out the bottom, and then cancelled the zeros.
Yeah, so you just turned them into the 300,000 over 4,000, cancelled everything out. You got 300 over 4, which is where I started panicking. It's like, wait, can I do 300 over 4? Can I really do that without a calculator? That's the bit I'm sure I got things like that wrong later on. I'm sure I did. But yeah, so I kind of treated like the whole thing in standard form and got the 3/4, although that's not technically standard form because that's not above 1, right? Anyway. But I knew the powers of 10, whereas you just kind of ditched all the standard form and it worked out fine. And that's, as long as you've got some sensible number awareness, this is the sort of thing where the method doesn't matter. Just be sensible about the number.
Yeah, exactly. Especially when it's only a couple of marks as well. Anna and her game. I remember Anna.
Question 6 was the first longer question, a probability question, although it seemed to be more about the artistic way of drawing a tree diagram than anything else, but
I spend like 2 minutes basically writing out what's happening, and then in my head I'm like, I'm clearly going to need to draw a tree diagram, and then I scroll down and I'm like, they're asking me to do that. Yeah.
And again, massive advantage of being able to write on the paper, which the students do in the real thing, whereas you have to draw the whole thing, but a lot of that work. So just in terms of time, actually, better to work on the paper. But hey, to be honest, you did fine. Well done.
So we just figure out the multiplying the events because they're all independent. Seemed all right. And then
it wasn't clear to me in part A though what they were after. It said the 4 missing probabilities. Now, the only reason I knew what to write were that there were 4 sort of lines on the paper to fill them in. I wasn't sure if they wanted me to fill in the probabilities at the end of the branches. I did, as you may have noticed, because
Well,
I
you
feel
kind
like
of
they're
needed to
they're
for the
relevant.
next bit, right?
Well, exactly,
That was,
exactly.
I guess. Yeah. I interpreted that as just the ones on the branches, like
Yeah.
you say, where those gaps were. And then obviously the part B was checking, do you know how to read one, i.e. independent events multiplied together.
And actually, I'm just going to show a glimpse of your working here. Look, this is your tree diagram, very finely drawn thing here. But I really like the fact that you did the first part in black, and then the bits you were calculating for part B, which we haven't talked about yet, you did in red, and that really helped me as a marker know what to
good.
mark. So I commend you for the change of pen color. That because I'm a human being trying to figure out what the hell you've done. It helps to be able to separate that. So that's good.
So yeah, we just had to get the 4 totals, didn't we? 2 of them were losers, 2 of them were wins.
Yeah.
Add them up, and we figure out that the lose was more likely. But as it says, you must work out the probability of winning during that process.
Which was 5/12 in the end. You had to add the 2 outcomes.
Yes. There's lots of additional guidance given in the mark scheme. I'm just going to ignore all of that because you got it correct. It's fine.
So I found something interesting that the mark scheme for this has 2 pages of alternative guidance.
Oh, this did my head in on every question. I was like, right, Ben's got it right. Scroll down. Oh no, there's another page. Oh no, there's another page of
When you begin to see what a nightmare it is for examiners to mark scripts where they basically have messed everything up, but there are sort of all these conditions of like how you might be able to award a method mark because they've done something right. I think in the same spirit as you were saying earlier, that examiners actually are trying to be as generous as they can.
Yes.
And it would be horrifying if they weren't, to be honest. They would be just really mean. But at the same time, they've got to mark thousands of scripts, thousands and thousands of scripts, and have them sort of have some measure of equality, even though not everyone's marking them. So that ends up being really prescriptive, and it's super daunting. As it happens, marking our scripts, I think, was a lot easier than many scripts because mostly, speaking for myself, it was correct. But it's when things go wrong and how you can still award marks, it gets really complicated in the alternative methods. And I think this was the first question where it was kind of like a show that question, wasn't it? It wasn't quite because, but you had to sort of construct an argument about whether she's more likely to win or lose. And I feel like there were lots of marks suddenly, and it wasn't just a calculation. You had to come up with a conclusion, which is nice. I feel like that's what probability questions are for. It's not just what is the probability. It's then what does it mean?
Right, and it's 2 marks. Right, well, it gets the 2 marks. They've made that so much more difficult than it should be in the mark scheme. Not the question. The question was fine. Anna and her games. All right. Oh, I enjoyed number 7. About
3
the party.
friends at a party, yeah.
I think I made this one so much more difficult than it should have been.
Well, I feel like I did even
be...
more than that. You did a really simple... When I was marking yours, I was like, oh, well, that was easy. And I remember sweating a little bit over it.
Yeah, I don't know if this was just me, because I feel like these kinds of questions about proportional or percentage increase, it's like you know how they work, or at least we do as mathematicians, but they're very easy to just... It just feels like it's so easy to fall into a very slight trap and mess everything up.
So I think both of our instincts in questions like this are to jump into algebra, whereas nothing in the question mentions algebra. And I can imagine that students who are sort of algebra shy are desperately trying to figure out, well, if it's gone up by this bit, it must have tweaked by this amount. Whereas actually the algebra just codifies all that, and you stop worrying about the context and you solve the bloody equation. But your bloody equation was much simpler than my bloody equation, because I had like... 3 friends arrive, their arrival increases it by 20%. In total, how many people? So I was like, well, if x is the number of people, then x plus 3 is the same as x times 1.2.
Yeah.
And whereas you were like, well, 20% is a fifth. So a fifth of the total must be 3. Yeah. And I'm like, and your entire multiplication consisted of like 5 times 3, and then well, that was what. So that was.
I did then double check it using your method. So in the actual video, I sort of talk out loud about checking it because because as I said, I always double check things like this because these to me are obvious things to just make very slight slips. Yeah.
Whereas I on my algebra on the paper, I had to do 3 divided by 0.2, so like 3 divided by a fifth, and I was thinking, look, I'm fine with that, but it's a really potential massive problem for people who are uncomfortable with dealing with fractions. Like the calculation I ended up having to do, I can imagine a lot of GCSE students who are not feeling confident just crash and burn, and I don't blame them.
Right, question 8.
Question 8.
Powers of 3s. Playing around with them. This one got me. The fact they put the divide sign. Like,
I hate that divide sign.
Yes.
It's up there with mixed numbers for me. Actually, I had to go and look it up. Do you know what that symbol's called? I'm going to get this
I
wrong
do
now.
not. Other
I think
than
it's
the
called
divide sign.
Yeah, well, I think it's called an obolus. Obelus. And I like the fact that I didn't know what it was called means obviously that nobody ever uses it, or no one should,
Yeah.
because all
Yeah,
it does
like
is
there's a
make
fraction.
calculations ambiguous, right? And messy.
I agree.
Luckily, they put enough parentheses in here or brackets
Yes.
to make it non-ambiguous, so I wasn't just like cursing the world. But
Yeah, no, when I first saw it, I was like, is this one of them where it's like only genius can solve? Like,
Yeah,
level of, can we not do this, please?
crappy viral maths on the internet.
Exactly.
Hey, go and read Kyle Evans' book about that one. I'm sure that's a worthy reference. But we both got this right, and we both just interestingly, we both rewrote it without the division signs using fractions,
and
right?
then fractions cancel your. Yeah, it's just working them out. It's working with powers, isn't it? The rules of powers. That's basically what the question was.
And like a big
Adding
piece of advice is get comfortable with fractions. If you're a GCSE student, fractions are your friends. Get comfortable with them because they'll make your life better. Believe me, even if they're scary, right? They're just better.
Oh, they make this so difficult. Right, 81, thank you. So he can have 3 marks because he's done that in a sensible way. Fine. I don't know how much you're supposed to follow the exact mark scheme here, but if I'm seeing something sensible and Ben has the right answer, I'm giving him the marks. I hope you're being as nice, Ben. Just gonna throw that out there, right? If your answer's correct and what you've done looks good, I'm giving you 4 marks. Please note.
Because question 9 was a diagram.
Indeed.
Which you had to
I had to redraw.
But you did well. You did well.
Yeah, no, I think we both. I'm guessing. I remember getting 11.5. I'm assuming I got 4 marks for this one.
You got full marks. Yeah, none of your marks have been lost so far. Although on the recording of the marking video, question 8, I did award you only 2 marks, but only because I didn't realise it was out of 3. I clearly thought question 8 was only worth 2 marks at the time.
Okay, so there's going to be other errors. I'm going to look out for all these errors now. I
had to go and resurrect.
I feel like 73 is too low. I'm not happy.
Yeah, well, I am going to be the first to admit I'm not a perfect marker. I'm mostly perfect. But yeah, there may well be errors, so let's find them if we can, because to be honest, I would expect better from Tom Crawford. I'm just joking.
Agreed. No, agreed. Right, so this one was, I think we've both done it the same. You work out the area of the semicircle, you work out the area of the whole big one, and then obviously subtract off the semicircle, and then you've got your 2 areas, compare their ratio. One's 11.5 times bigger than the other.
Exactly, yeah. So it was 4 marks. It felt like it was quite involved, and I was thinking, I think a lot of GCSE students are going to stumble on this because there's a lot of bits to do. But it didn't feel like a silly question. It just felt a bit like, why? Why do I need to know how many times? Like, I feel like it's easier to ask a question why I need to know the area of the 2 bits. Maybe it's for manufacturing or something, but why the ratio? And then it wasn't a very nice number, which is the first, like, did GCSEs have bad numbers in the answers?
Exactly. I always say this to my students, like, if the answer is, I don't know, 19.7352, probably something's gone wrong in your calculation.
But not anymore.
Like,
no, I think there's more and more. Like, no, there was another one later on, I think, where the answer was like, ugh, yuck, have I messed this up? And I don't think we had.
Question 10. Right. Now, I noticed Ben actually used the square paper, so has an accurate graph, unlike me, if we remember. Graphs. First of many of me attempting to draw bad graphs, okay?
I'm going to warn you, this is the first minus mark on the script.
I am going to say that I completely disagree that I get a minus mark on this, but we'll see.
I'll justify my thinking, and if you can talk me into getting the mark back, we'll see what happens. So it was a graph, a reciprocal graph, 60 over t, and on the grid below, draw the graph. I mean, first of all, Tom, it said on the grid below. I don't know where your grid went.
I already explained this to you. I couldn't figure out how to draw on the PDF, so I had to draw on a different app. I would have drawn it on the. Obviously, you've said yourself. I was adding extra difficulties for myself, having to redraw everything.
I'm not going to give you bonus marks for being difficult, all right? But I do appreciate it. It's actually much harder to do it without that grid there. So it's really important, actually, GCSE gave that grid, because drawing a sketch graph from scratch, actually, I think is a good mathematical skill to be able to, from nothing, get an image of what the function looks like. Which, by the way, you did very well. I'm proud of you.
Thank you.
But
so I did get the 2 for the drawing then?
No. And I'm going to quote...
Because it says do it on the graph, or...
No, I'm going to quote you the mark scheme now.
Oh, here we go.
Shall I show you? I'm going to show you the mark scheme. I'm going to put it on
My
screen.
graph's really good. I'm not happy about this. I think my graph is excellent considering
I felt like there was enough black and white instruction in the mark scheme for me to... I didn't have a choice. Are you seeing the mark scheme now? This is question 10.
Yes. Yeah, we can see that.
And there were 2 marks available. There was a method mark. N stands for method, brother, and A for accuracy. I got used to think that was answer mark, but it's accuracy, right? And it said plot the points, blah, 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 and blah. And I believe, just having a quick look at your work, just so everyone can see it. Are you seeing that? You did plot the points, and I gave you the M1 mark, I think. So I then looked back at the mark scheme, and it says a correct smooth curve through the correct 4 points. That's for the A1. So this is the mark that I had to look. This is what killed you, I'm afraid. The curve should be
no feathering.
a single line.
I'm so not having
no
this,
feathering.
Ben.
I'm just going to show you your graph again. I'm going to zoom in on that.
I'm very aware, but I'm still so just not having this. But no, it's fine. Okay, you have shown me the correct phrase. It does say that that it has to be a single smooth line.
And I think if you just feathered it a bit, I would have been like, I know what he's doing, fine. Or if you just done 2 lines, but because it was kind of feathering and more than 1 line, I'm like, if I was doing this for the exam board, I would get pulled up by the lead examiner for not marking.
Okay.
But I also feel terrible that you're not getting a mark, because what you then did was used your graph, as they said, to get an estimate, and because you'd done it on paper, it was a sketch graph, and you got exactly the same answer as me on the printed graph. I feel like, well, fully justified. However, I just thought it would be a good discussion point, because any student doing that would lose a mark, and I kind of hate it.
I'm still unhappy, but I completely agree with your marking, actually. I hadn't even thought that would be a thing, but I guess it's a valid point, because the question is about like sketching or drawing a curve, and I do this all the time when I draw graphs. I never just draw 1 line. I always do it several times, because I'm aware that it's a sketch, and so I just want a rough idea of the shape.
Exactly.
So,
and
but obviously,
what's crazy as well is it's asked for a value of n at the end, and it says an estimate, but like it doesn't really communicate how much of an estimate is going to be, like plus or minus 2 or 3 based on the shoddy nature of line drawing and stuff.
Exactly,
But hey, so I don't think you deserve to lose a mark, but the mark scheme says you did, so you did.
Okay.
I'm sorry.
All right. No problem. But then we both got...
one down.
So obviously yours does have a nice single line. Well done. And then we both got the estimate, didn't we, with the 17.
I did try to do it in a different colour just to make sure that you were noticing. Although I didn't use a ruler to draw my lines, because I'm working on a screen and things. And
it still works, yeah. Oh, God. This mark scheme is worse than the exam. I think the answer's meant to be 45, yes. And he's done something sensible there. He has done something sensible. All right, 3 marks. Nice. I think we both, when I was reading your solution, I was really happy to see that we both immediately looked at it and thought, we need to divide by 11. Oh, look, 330 perfectly divides by 11.
Yeah, it was a relief, wasn't it?
Kind of onto a winner from that point.
I found this question surprisingly non-intuitive at first, but it does feel like the sort of thing you argue about someone with in a pub. Like you've paid for something, and you're like, you just got to sort out who owes what, and you're like. So actually, I kind of liked this question, because it didn't feel like learn the method and do it. You've just got to sort out what do you owe Faye or whatever.
It's a good like real life example. I agree. I thought it made you think. There was some interesting maths, ratios, division, etc. I thought it was a good question. Happy with that one.
And we both wrote down a similar sort of style. Like we got it down to 210 and 120 for the 7 to 4 bit, and then both wrote down, like as if by magic, the number 45, because we could see that that's the bit you sort of like tweak and adjust.
You need 165 each. How did you get there? Yeah.
Actually, it was 165. We wrote that, and then 45 appeared in both of our working.
Yes.
But there was a lot going on in our heads to justify that. Luckily, it didn't say. Prove how much, like, or show all the steps, so I don't think we could got marked down for the slightly non-linear way of thinking. Anyway, we both got it right, and that was a nice question, I thought.
Sequences. Oh, I enjoyed this one, because I don't know if you did the same, I just checked the first one first. I was like, oh, it works, and then quickly checked the others failed.
Yeah. At least the first one was right. You feel confident, like, well, I think that's going to be the right answer, and the rest is just a check-in exercise. It was interesting. I did spend a little bit of time thinking about why they put the other sequences in. Like, what were they trying to catch them out with? If they,
it was the pluses and minuses.
Yeah.
It was, yeah.
And the question is hard because of negative numbers, isn't it? It's it's testing whether you're comfortable enough with negative numbers, which is a really sort of normal thing to be a bit uncomfortable with. They're a bit confusing at best.
Yeah.
Hey, but you did fine. Well done. I think I'm super patronising today. I'm not meaning to be, really. But,
well, it's my turn to be patronising because,
is it?
Ben, you did not get full marks on question 13.
I know. And
what did you do wrong, Ben?
well, I haven't marked it, but I'm pretty sure I did some brainless calculation issue. But I'd love you to explain what
It wasn't brainless, but it was a calculation issue.
So what's the question was volume? Oh, it wasn't the volume of a prison. It was. This question got me actually.
You had to estimate.
Yeah, because of the estimate. And again, I think that's a GCSE command word that has a certain meaning that I had no idea what it meant. And
Me neither, to be honest.
I'll tell you what. So let's looking at yours. Well done. I gave you full marks. What you did was wrote down an equation that calculated the value of the volume, which we both did, I think, exactly with the exact numbers. Yeah.
Times 8.14 has to equal the volume we're given, which is 102.
102.
Yes.
Yeah. And then you did. You halved 8.14. Maybe shall I put this on the screen? It's easy to work it through there. So you halved 8.14 to get that. Then you divided by 4.07, and then you square rooted. And only at that point did you start estimating. Yes. And the mark scheme, the first method in the mark scheme, was a bit surprised about this because the first method was like they should estimate all the numbers, and then it would be simple calculations. Yeah. But there was one point in the mark scheme, I think, that said if you see that calculation, that 100 over 4, at some point, then you can give at least one of the method marks and maybe two. And so I saw it at the end. I was like, well, that's a relief. I can give him full marks. And then I saw the 5 and I was like, my memory was like, ting, 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 ting. Wait a minute. I don't remember writing 5 for this question. So what did I do?
So what you've done is you did do the estimation at the beginning. So you've got a half x squared times 8 equals 100.
I decided that I thought estimate meant round everything to one significant figure, which Rob Easterway, he did a number file video about it. He said, look, let's call it the equals method. If it approximately equals, just do everything to one significant figure all the time, and everything will be simpler, and you'll get a pretty good to one significant figure answer.
Yeah, exactly. Yeah.
That was the rule I decided. But
So no, that was all correct. And then you said a half x squared is 100 over 8, and then you said x squared is 200 over 8, and you simplified that to be 100 over 4. So you got down to x squared equals 100 over 4, which is all in the mark scheme and is all where you should be.
Yeah.
And then for some unknown reason, you wrote answer equals 12 and a half. And I have no idea what happened between x squared equals 100 divided by 4. I think what you've done maybe is divide by 2. I think you've done 2x.
So I had to square root still, didn't I? So I hadn't done the square root by that point. So I'm now looking at my answer thinking 100 over 4. And then I think I must have been panicking, right, under pressure or something, trying to go too quick. And I reckon I thought 100 over 4 is 25.
Yeah.
No, I think I got the 25 from the 100 over 4 and then kind of forgot that I'd used the 4 and thought, oh, but I'm square rooting. So the 4 became a 2 when I square rooted.
And I see. But then, okay, fine.
It's just nonsense.
Yeah, it was a bit confusing. But you got 2 out of 3, I believe, according to the mark scheme, though. Because you made the approximation, and it said, I think if you wrote x squared equals 100 over 4, I think you got 2 out of the 3 for that point. Yeah,
there's M1 for anything being rounded, it looks like.
Yeah.
Maybe I'll put this on the screen, because it's interesting how easy the marks were to get, right? Even if you messed up as badly I did.
If I was being completely honest, if I was marking this without a mark scheme, I feel like what you did would be worth 1 out of 3.
I agree. It was that sort of stupid, really.
It wasn't stupid, but it was like, it felt like you were quite a long way from, like, the key part of the problem was the square root. So
and I didn't.
Quite a long way away from
and I didn't check the answer either, which would have been a major red flag, like something's wrong. Comment earlier that you said check your answers, flipping out. But I would have got 1 method mark for any of those roundings there, which is quite generous, and then another method mark dependent on the first one, as long as I've done something rounded for like any of the calculation construction, really, and then the accuracy mark. For getting 5.
Answer,
as long as you got both method marks. The thing for me that I think, actually this might explain, I'm trying to make excuses now, but might explain my irrational blip there, was that I was super relieved that we'd got an x squared equals 2 square numbers. So that when we're going to square root it, like, it's going to be possible. Otherwise, what's this doing on a GCSE non-calculator?
So you were thinking it would be like square root. I got
which it is. Okay. It's 10 over 2, otherwise known as 5. But moron over here decided
Well,
that
there's only
25.
one mark.
Yeah.
There's only one mark. We've both lost one so far.
It's galling when you lose a mark to
agree on.
realise how tiny slips like that just lose you the marks. But you're right. We've only lost one mark each so far. So I think that's a good question, although I dislike the sort of blurry, what does estimate mean? And actually, I need to go and look up what do they actually want them to do, other than just do something sensible, which is maybe the best interpretation of it.
First mark dropped. Question 13, though. Pretty good going, Ben. Well done. Right, 14. But he did get 2 out of 3, even though he got the wrong answer. So important to show you're working, everybody.
So question 14 was a quadrilateral.
I had a lot of fun with this. In the video, there's just loads of clips of me going, I'm sure the angles have to be 360 degrees. I'm sure that's a rule. I couldn't remember whether or not it was. I now know it definitely is. But at the time, I was like, I think that's right.
Well, interestingly, I wonder if we could come up with, if this is what's true about maths in general, I think, is that you can get away with doing maths, GCSE particularly, if you learn lots of stuff. But in both cases, both of us at this point, we're a bit unsure, I think, about, have we learned that? But the nice thing I feel about maths is that even if you don't learn the stuff, you should be able to convince yourself of the truth, mostly, even if you didn't learn it, right? You can almost derive it from scratch. So how can we convince ourselves that a quadrilateral has 360 internal angles? Any thoughts?
I just thought about the pattern that happens with shapes. So I know that there's the general pattern of 5 sides being 540, 6 sides 720, based on a pentagon. A regular pentagon is...
Because you knew about pentagon internal angles. Yeah.
I knew that. I knew the total of a hexagon was 720. So I just began to see there was a pattern for the regular shapes, and I felt like similar to with a triangle, I feel like everyone knows a triangle is 180.
I was going to say, that's the fact that I feel like we've all learned, right? And it all sticks with a lot of people, doesn't it?
That one's stuck in your head. So then I was thinking, I don't know, just it generalized more, and I was like, well, you've got an equilateral triangle, which obviously is 180, but it's true for all of them. You've got a square, which is 360. It's probably true for all of them. That was kind of how I rationalized it in my head.
And what's nice as a marker then, none of that uncertainty that you were feeling live came through, because you just glibly wrote down total equals 360.
Yes.
Obviously true, clearly true, facts. Use it, and then we had to prove that b equals x, which worked out they're both 54.
There was a lot to do here for 3 marks.
There was a lot to do.
I felt like, because you had to do the ratio bit at the start. You had to do the ratio to get what b actually was.
Yeah.
Right. Figuring out that it was 3 times 18.
Yeah.
We both did that slightly different, but we got there. And then you had to spot the relationship between x and y, and then you needed the total is 360, and then you solved for the actual answer.
And it essentially the way I did it, I had calculate b and calculate x, and then they happened to be the same number. I felt like maybe there was a way just to show they're the same without needing to know their number, but to be honest, I was so glad that they were the same number. I was like, right, move on.
That was how, I went in the same thing. I thought, I'm going to calculate b because I can see how to do it. Can I figure out x? Yes, they're the same. Yeah, rather than trying to use an angle theorem or something.
I'm going to say one more thing about the quadrilateral being 360 point, because I was really relieved when I had this exact same doubt of like, oh yeah, is it 360? And I fell upon what I think is actually a neat way of justifying to myself, because I knew the triangle thing, like you just said. I know that triangles have 180. I feel super confident about that. In fact, I'm sure I could prove it, but I didn't feel like I needed to. And then I just realised, oh, it's quadrilateral. You can divide it into two triangles. Two triangles.
Can, yeah.
And then I'm like, I'm done.
Yeah.
And but the same way for any pentagon, I can get into 3 triangles, and then I know the pattern going on, and I felt happier at that point to write down my equals 360 equation. But it's amazing, like the self-doubt you get in those moments, particularly under pressure, GCSE pressure. Yeah. Anyway, full marks both of us, so I think we're all good on that.
Draw the cumulative frequency graph. Again, he's actually using the square paper, so it's actually accurate. Stats question.
Hey, did you love this as much as me?
It wasn't that bad, apart from, I'm going to guess, do I lose marks again for drawing a bad graph?
You did not lose marks on this question.
Yes! Okay, I learnt my lesson without realising it.
5 marks available. You did do a graph, and I was, having realised, I was feeling guilty at this stage for docking you the mark earlier. I was like, but if I've done it once, I'm going to have to do it again. And I looked very carefully. I'm going to show everyone again. This is the graph you drew. I know we skipped on to part B, really, but part A was just adding up some numbers, right? Was it? Complete the cumulative frequency table, add up the numbers. Well done, we all did that correct, which is a relief.
Yes.
But your graph is actually really nice. It was a single line, and it was not feathered, so I'm like, have 2 marks. Really nice.
Okay, good.
And even better because you didn't need the paper to do it. That said, we ended up with very different estimates when we used the graph, and I think that was purely down to the fact that your scale was necessarily hand drawn and not.
Of course, yeah.
But interestingly, again, the mark scheme allowed for that. It just said use their graph.
As long as it's accurate, yeah. As long as they've read their graph correctly, whatever their graph is, yeah. I feel like yours, now I can see that your answer is 32 and mine's 40. I feel like yours is probably actually what the answer should be.
Yeah, but in the mark scheme, they don't even say what the answer should be. All 5 points plotted, smooth curve or polygon. Interesting, they could have done straight lines, would have been fine, according to the mark scheme.
Yeah.
And 15C, correct reading from their graph.
Perfect, yeah.
That's it. And I was like, well, your graph's tiny bit shit, but didn't lose any marks.
Ouch!
Only in the sense that it was the graph that I would have drawn on a piece of blank paper as well, and it suffered from the scales being not super regular, not perfect. But from your graph, I would have nailed 40 as well, so you got full marks. Well done. I'm being hypercritical, but it's nice to see that the exam guidance is that prescriptive, and they know how to give marks if something's slightly unusual, like if the student didn't bother doing it on the right paper. Sorry, I'll stop going on about it now.
Right, 16, some simplifying an equation. So you just had to spot the common factor, didn't you, in the top and the bottom?
Yeah, what's the answer, Tom?
That's the key. Minus 2x over 3.
Yeah.
Is that not what I wrote? I don't know. I don't remember what I wrote. Oh, no way! No way!
I'm not gloating,
is that on the mark scheme? You actually have to simplify that.
Do you want to see the question again?
No. It does say simplify fully.
It does say
fully. Does the mark scheme specifically say it has to be 2 over 3?
If the question said fully,
that's a silly mistake from me. I know. I obviously should have done that, but I think I probably got too excited by the fact that you were cancelling the big.
The brackets cancelled really nicely. It's super satisfying, and that's what we all live for, isn't it? In fact, I can't remember if I've watched this bit of your video, but we're both for me, when I got to that question after the stats question, which was a bit painful.
We were
like algebra, yay! I sensed the excitement in your answer. You got so excited, but the mark scheme is on screen now, and you can see the accuracy mark is given only for the 2 and the 3. There's no mention of that. You can see a method mark is given for the 4, 6. So I can't give that a mark, which is sad.
That's a silly one. Yeah, that's a silly one.
It feels like that's much more like the mistake. Like it's a sort of blip, like too excited, moving too quickly. The feathering mark, I agree, was more controversial.
It's hopefully the kind of thing that both of us would have spotted if we'd have used the additional 30 minutes we did have
to check our answers. Yeah, absolutely. The additional guidance for that was quite explicit. It's like you allowed negative 0.6 recurring if you'd gone decimal, as long as you did it correctly, you could have got that. But because fractions are your friends, you stuck with fractions. And it's just a shame. It did say simplify fully. It's the sort of mistake that really good GCSE students would still make, and it's frustrating, but they'd only lose 1 mark, like you did. So.
Good old Toby and his equations. Enjoyed this one. Right. It says solve this question mark. Not sure what's going on there, Ben. I mean, are you asking me to solve this as the marker? 17 was fun. How you kind of wrote solve this question mark. I made a comment when I was marking, being like, wait, am I supposed to do this for you, Ben? Are you asking your marker
it was a challenge to
answer the question? Like
I watched your opening this because I think I watched this segment of yours a little bit just to see how you got on, but both of us commented question 17. We both read the question. Toby is forming and solving equations, and both of us were like, well done, Toby. Yes. Good behavior, Toby. Good for you. It does beg the question why, and because he never got to solve it, I'm like, was that as far as he went? He just because it said he was forming and solving them, but this one he only formed, and that's why I wrote solve this.
He tried to solve the next one, didn't he? Yeah, I feel like it seems odd that you form the equation in the first part. It should feel like the second part should be then solve that equation you formed.
I agree.
They kind of anyway.
I wonder if the first draft of this it had something like that, and it got edited out. Who knows?
Maybe.
But it was an easy 2 marks, I think, for both of us there. And then part B was the classic mark someone's error. I do like these questions. I think they're hard in an exam, but they do test understanding.
Hard. For 1 mark, this was probably the toughest single mark question on the paper. Like,
I think what I'm glad about
it
is that the fact that these questions are now more often on GCSEs. They didn't really used to be. This is like testing a bit more of a problem solving, sort of big picture thinking.
True.
But because they're on there now, it does give a much better excuse for teachers at GCSE to do this sort of exercise, to make people pay attention to what misconceptions are likely to happen. And I think that's good pedagogy. And the exam is actually backing it up. All too often exams make you just learn stuff. But this is rewarding familiarity with misconceptions, which is a great thing, I think. And I think we both wrote the same answer. We both wrote something about square rooting the 9 and not the 8.
He forgot
square rooting the x and not the 8. But the mark scheme didn't actually... It was not in any of the guidance for the mark scheme. I was hunting through. And eventually I found something which basically just said, look, if it's a correct comment, give them the mark. And I'm like, yeah, your comment's correct. But all their example responses were things like, he has taken it as 8x squared, like in brackets, which would be, or he is divided by x instead of square rooting, which would have done the same effect. And like, and you suddenly realise there's loads of ways.
I agree with you. It's the root 8. He's forgot to square root the 8. That is the. But anyway,
it's interesting that we both interpret it like that, and the mark scheme doesn't. There's literally like tens of example comments, some of which get marks,
and none of which we wrote,
and some of which don't get marks. Like one of the example comments is, he didn't divide by 8, and it's like, well, yeah, he did. Apparently, if they write that, don't get a mark. It's always fun to see the example comments where it's given 0. It's like the examiner's like, moron. Here's a moronic comment.
You know he's a teacher if he spots the mistakes. Very good. Right, number 18. What were we doing? Here's an identity. You need to work out. This should be 36,000. Oh, Ben, what have you done? 193 minus... He's done 193 minus 9. You silly sausage.
So question 18 said, here is an identity. And that gave me a little pause because I thought the idea of identities, which is really important, was only really discussed at A-level in school and a bit out of date.
Right.
That GCSEs get to mention it. But then I saw the identity and I was like, well, okay, of course, it's this one, which I know we both feel strongly passionate about. Everyone should know. Like, it just comes up again and again. Difference of 2 squares, yeah?
The way I thought about it was they'd written, here is an identity, and I assume that must be like code for GCSE students of, you don't need to prove this or worry about it. This is something you can use. I think is why they've called it here as an identity.
I wonder,
that was my interpretation.
I'm interested in the fact they did use the 3-line equal sign, which again I've taught to A-level students, but I don't remember teaching to GCSE students when I was a teacher still.
Right.
But hey, it's good notation, and actually I'd be glad that GCSE students know that some things are always true and other things are equations which are sometimes true, like which you can solve.
Interesting.
Anyway, I have a bad feeling about this question and my marks.
You did lose a mark here. This is your second drop mark.
What did I do?
You made a slight error. So you split it up into the 193 and the 7, and obviously you do 193 plus 7 multiplied by 193 minus 7, but you said that was 184.
Which
so you've
it's
subtracted 9.
Not.
It's 186, isn't it?
What was I thinking?
So
something about
I think it's
7...
just a classic calculation slip, isn't it? It's an awkward one, right? When you're subtracting...
You know what I did?
Minus 7. It's a tricky one. But
well, this I can now see I'm looking at my script and I'm now remembering the slight mental process. I was like, right, it's a 3, take away a 7,
and, then a 4.
I know 3 and a 4 go together make 7, so it's a 4, but it should have been 4 less.
Yeah.
Ugh.
Yeah.
I then did the calculation correct, but I wouldn't have got any credit for that. So I guess I got M1A0 for that. Is that
yeah. Because I think the first line you wrote out, 193 plus 7 multiplied by 193 minus 7, that was the method mark.
Yeah.
So, and then it's just...
And this was a must show your working one. So actually, even if they got the answer correct, they wouldn't have got any marks. Is that right? I'm looking at the mark scheme now. 37,200, which is the correct answer, with correct method not seen, scores nothing. Literally nothing. Which is
harsh.
Well, I guess they said.
It does say you're right. It is the first. Well, not the first one, but it's one of the few that we've seen that say you must show your working. So it is clear.
Nice. Okay, so part B then was a factorize.
Yeah. Just spot what was happening, which I think for both of us was super easy, but I can imagine that being quite tricky.
I agree.
For people who aren't familiar with the difference of 2 squares. Possibly.
And who don't feel this sort of spectacular elation that we both feel when we get to use that little trick and like, it's going to be easy, I can just write it down.
Yeah.
And question 19 was like a 1 marker. Again, this is it's a B mark in the mark scheme, and B stands for book, I think originally it stands for like a thing you've learned from the book.
Yeah.
So you can just write it down. But I feel like if you've spent any time working with fractions and decimals, this is like, well, of course it's a ninth. And I know this one.
Yeah, no, that's what I thought. But then I think I also actually wrote a little bit of working, but then realised that it was one of those questions when you didn't have to show any working. But
Yeah, I started scribbling on there as well, but I can't
yes,
remember.
I can see. We both like added working completely unnecessarily because, as you said, we both immediately knew it was a ninth just because we're used to working with decimals.
Before we leave question 19, I do need to show you what I wrote on this because you did a little bit of extra work.
Nice proof. Hey, so I thought I didn't. Yeah,
you did the proof. You did the classic let x equal this thing, do some multiplication, do some hand wavy about infinite decimals expansion, which clearly line up and you can subtract, which you can, but I think needs some justification. But you never do the justification at GCSE, and then I like it. I like your smiley face end of proof symbol as well. That's a pleasing moment for me.
Good. There's a couple more of those, I think. You can tell this is the point of the exam where I'm kind of, I don't know whether I'm losing it or what, but I'm like starting to draw.
Oh, I can do this. I'm going to do a proof.
Yeah.
Unfortunately, the next question was a proof question, wasn't it?
Okay, question 20. The one I didn't like. I bet Ben's going to smash this now, isn't he? Well, we'll see. I am guaranteeing that Ben will know his circle theorems before I've looked at this. I think he will know his circle theorems. Let's see. As I didn't. Still don't. Probably should look those up. This one. So I'm going to just immediately, and again, I say this in the video, I do not know my circle theorems. So I was just so lost on this. I spent like 5 minutes in the video just being like, I can't remember my circle theorems.
Yeah.
I just cannot remember them. Like, that's what I meant about something that you learn for GCSE,
And
possibly
never
in
touch
A-level,
again.
I can't remember. And I've never used it ever again. I'm not saying it's useless, but it's just not something that's ever come up for me being an actual mathematician.
And I think this question particularly uses one of the circle theorems that is traditionally the hardest one for the kids to remember at GCSE, and the one I've used least often going forward.
Yeah, I know you wrote down all the names and everything. Like, this is why I want you to explain this because
really
I don't. So I gave you the marks because, as far as I could tell, you're using what the mark scheme says you should use. But I will be honest, I have no idea what the alternate segment theorem is.
So the hardest thing about this question as well is that the diagram got used for part B as well. And I think both of us added to our diagram when we were looking at part B. And so the diagram becomes a very unreliable guide of what we were thinking. Shall I talk through what I did? Because I think this was the hardest question on the exam. Is that
Yes, yes, it definitely was for me. You know, I would love to, because as I said, I can read your solution, and I gave you full marks because it looked similar enough to what was written in the marks scheme. With my very oh yeah, I think that's right, I'll give him the marks. Being
Are you
the super
seeing
generous examiner that I am?
I'm going to draw a little bit like your hand-drawn version. Oh, look at that circle!
It's pretty
I'm dead impressed with my circle. Sorry, that's never going to happen again. Oh, I'm pleased with that one. There's an A, there's a B, and I know that the question, we might pop the question up on the screen already, but hand drawing a diagram, actually, I always find really useful. So all my comments about you hand drawing stuff, I quite often
I would do it
redraw
anyway.
a diagram anyway.
Agreed.
Forces you into
Same.
thinking, doesn't it?
Yeah.
And I think I watched a tiny clip of you, because this is where you lost marks, right? This question.
Yeah.
And I watched you thinking about it, and there's a tangent here.
Yep.
And both of us thought long and hard about why that makes 90 degrees with the line to the center, because that's a circle theorem that I think we've all used going forward, and you remembered
that one
it, and I
have
remembered
used.
it.
Exactly, you use that all the time,
Yeah.
But not. But
this is not
the center,
because the center's not involved in this, and even if you put it in there, well, I think you can solve it if you put it in there and did lots of work. But hey, that's not what they were testing here.
Yeah.
Incidentally, I think that's how you prove the alternate segment theorem, which was your only get-out clause if you couldn't remember it.
I didn't know it.
Yeah, and it was going to be a hard proof to do anyway. So let me just catch up with the question.
That the triangle ABC is isosceles with AC equals BC.
So both of us, I think, put a marker on like that to indicate that. Confusingly, later on, the other side gets involved as well. But part A, it was just this, wasn't it? And they also told us that CD is a tangent, which has made all of us think about right angles, but that didn't help. So it wants me to prove AB parallel, is that notation okay? Parallel to DC.
Yep.
So I got stuck straight away, but because of the isosceles triangle, I think I immediately labelled these two. And I think I probably called them... Well, actually, no, I wrote down a reason straight away. I said angle ABC is the same as BAC. Brackets, isosceles.
Isosceles, yes.
And
Yeah,
actually,
I got that. I was happy with that. This is so far we're in complete agreement. This is where I got to.
and I think I gave. No, see, I couldn't give you the mark for that, even though I know, having watched your video.
Oh, that is
you thought it.
controversial. I swear that was the first method mark. I swear that was the first.
Okay, let me finish the proof, and then we'll dissect why. Spoiler.
All right.
Oh, maybe I give you 1 out of 4 for part A, and maybe that was the mark that you got.
Okay.
And I'll show you why. But 3 marks down is the biggest step we've seen in this paper anyway. So first of all, those angles are the same. We both know that because it's isosceles, and I think that was worth 1 method mark. Then, and this is the classic one. So the alternate segment theorem, I'm going to draw it over here, says if you've got a tangent touching a point on a circle and you draw a chord that touches where the tangent touches, then the angle off that chord...
Sort of like Z angles, right?
Well, it's in the other segment. So the angle between the segment and the tangent, and then the angle in the alternate segment, the other side, are the same. Yeah, that's what the alternate segment theorem. And you can see how that's useful here, because in this case, you realise that that one is the same as that one.
Okay, right. Those two are the same. Okay.
Yeah, those two are the same. So can you see how... But then because these two are the same as well, we've got...
That's also the same, right.
That one and that one being the same, and that is the Z angles, although you can't call them Z angles and expect to get a mark, I think.
Right, okay.
In the GCSE exam.
I see. So you've written alternate segment theorem to get the ABC angle
so it's
as
DCA.
Yeah.
So it's that one and that one. And then you can, like, from those 2 lines, you get this one, which is therefore, they're called corresponding angles, which proves they're parallel. And I had a big doubt about whether this is the converse of normally
angles.
If you've got parallel lines,
it's because they're parallel, you know the angles.
Yeah, whereas this time I've got the angles.
Other way.
And I'm like,
got you.
I'm pretty sure it's an if and only if, but I was like, do I need to prove that? I don't think I do. I'm not going to. So I think the mark scheme was looking for those 3 things. It was looking for... Well, actually, let's have a look at it. Let's have a look at the mark scheme.
Okay. An alternate segment theorem. He's literally wrote alternate How do you know this? I mean, this is... Fair play, Ben. You've got the marks going to the mark scheme, but, like, alternate segment theorem. What is that? Not happy. But anyway, well done. You have the mark. It's on the mark scheme. Alternate segment theorem. This is nonsense. Because I read the mark scheme, right? I read the mark scheme, and I still didn't know how to answer the question.
I don't blame you, because I think it's a hard question.
They don't tell you what the alternate segment theorem is.
They
They just state it. And I have no idea.
So they're down... Are you seeing this on the screen now? ACD equals ABC.
Yeah.
So that is the alternate segment theorem bit, I think. ACD. Yeah. And then the next line is ABC is BAC. That's the isosceles thing. And the comments say, except both with the same letter on the diagram. So if I flick over to your script, because you'd labelled them with X...
That's for my isosceles,
I could give you that M1 mark, I think.
Yeah, cool.
But then I couldn't... So I've got an M0 label up here because you didn't reference this angle at all, and so that's my red marking there.
Yeah. I got lost, yeah.
And at that point, I think all the method marks are dependent. Like, so this is M1 dependent.
I see. You have to have those earlier 2.
Exactly.
To get that one, and obviously then to get the answer.
And the accuracy mark is with M3 awarded. So once you'd lost one of them, the dominoes had all... Which is what a proof feels like, isn't it? But
yeah, if you don't know the alternate segment theorem, I agree that I cannot get more than 1.
Well, I think this is a tough question for GCSE, but I'm again glad that GCSE has now changed slightly to include rigorous proofs. Now, they always kind of were in there, but in practice, they weren't tested very hard in the exam. And I think this is about as hard as the reasoning for basic circle theorems gets.
I agree, yeah.
And giving 4 marks for it is a chunk of the marks in the exam. So without knowing the circle theorem off the top of your head, I am not surprised that you ended up losing marks. I've still got loads of writing on my face, haven't I? Let's get rid of that. But then, unfortunately, and sorry to break this to you, meant part B lost a mark as well.
Yeah, I guessed. I completely guessed because I didn't know exactly what was going on. So I knew that AB and DC would be parallel, and I hope you're impressed with this. An equilateral is still technically isosceles.
Yes.
So therefore, everything we've done in part A would also therefore hold. So I was like, they have to be parallel for that reason.
And I remember watching your description.
And I completely guessed between the other 2 because I was like, well, I don't know. So I'm guessing, did it rely on the alternate angle theorem again? by any chance,
However, so you tick the top one, which is like, of course, it's still true because you've generalized from this is now a special case of the first one. So, but it's the AC bisecting BCD, and actually, there's a nice comment to make about this. So, AC bisects BCD or AC bisects BAD. So it's this line here either bisects that angle. That's one of them. BAD is it, or that angle, and you just tick the wrong one. And the only so I was doubting myself as well. But I did just check, like, because this line and this line could have met at a different point. They could have met up there, and everything in the question would be the same. And that means...
So obviously that other angle would have changed,
although it could bisect, I'm like, that one's not fixed, so this must be it. And there are other reasons as well, but that was the only reason I got to in the end. And I felt like that was using decent geometrical reasoning about, like, invariant and variant points to get there. This is a tough question.
I'd literally lost the will to live on question 20 at this point. I was like, I'm done with question 20. Can I please move on? Like...
Well, and you really get a strong glimpse of what it feels like to be a 16-year-old sitting this exam if you haven't got a nice, friendly relationship with things like circle theorems, or, dare I say it, with maths in general. The anger creeps in pretty quick, doesn't it? You're like, why do I care?
Yeah,
ticking random boxes.
It put me off. I certainly feel like part A... put me off definitely from doing part B. I'd had enough and was like, right, I'm just moving on.
But if it makes you feel better, I spent a long time on 20 and I was doubting myself about the proof, particularly because I was like, I'm using a converse of a theorem I thought I knew. And I had a sense of relief on question 21.
I'll be nice. I'm nice to my students. All right. So I'm pretty sure Ben knows what he's talking about. I still have no idea what the solution to this question is. And it's just mentioning names of things that aren't explained. But it's in the mark scheme. I'll give you the benefit of the doubt, Ben. I'm pretty sure you do know how to do this one. Well done. All right. I'll give it you. So, simultaneous equations, right?
Yes.
Brilliant. We know how to do those.
You got full marks on this, by the way. Yeah.
Yes. So
Did we do it
have
differently?
just substituted in? Or did you... Yeah, you've substituted in. I subtracted them.
I substituted in because...
Yeah.
They give me the second equation in the form y equals. I was like, well, I'm just going to use it. Whereas you rearranged it so that you could sort of subtract the two, which is a completely equivalent method. And actually, a lot of GCSE students prefer that subtraction method because it does feel like, even if you panic, that algorithm of like line them up, try and get a coefficient matching and sorting it.
Yeah.
And particularly because when you lined them up, that the 2x and the negative 2x were like, they're going to cancel.
Yeah.
So actually, I think your method got you there quicker and more smoothly algebraically. But that's the point, isn't it? Unless you do lots of practice at algebra, you sort of fall foul of the fluke of whether the algebra pans out nicely or not. And
true. Yeah.
If I'd done my method, even if it's correct, and was less confident in the algebra, I think I would have tripped up more easily because I had more fractions to faff with.
So he's saying that C to D is the same as going from C to A and then A to D. Yep. So I did it. Right, 22 was vectors. That was... I quite like this one. I had to think for part B. So part A was just about retracing, realising that you can add vectors in any order to get between 2 points. Kind of idea, wasn't it?
And it was just a question of remembering how it works, doing the addition, and then smiling in relief when it's the answer that they got.
It was the answer they were getting. Yeah, exactly. Yeah. But part B I had to think about.
Yeah,
I
well,
sort of remember that you needed, and you've written your like lambda as your proportionality constant.
Way too complicated, and I messed that up for a while because I think I'd written lambda on the wrong side, which you can still do, but it ended up confusing the hell out of me.
Makes it a bit harder, yeah.
It wasn't the wrong side. Anyway, I nearly knocked your mark off for this.
Really? What? How did I nearly lose a mark?
Can you see what it says in the question? There's a bit in bold.
You must show your working. Did I not show my working?
Well, this is what
just about enough, I'm guessing then.
Well, there was a get out of jail free card in this one, but I completely agree with your reasoning. There's part A done 1 out of 1, and then you said BC was that by going that direction, and they got you a method mark, and then it says we need same ratio of amounts of A and B, and I can see your reasoning. So K must be 4 to make that fit that.
Really should have shown that dividing the two numbers and things. Yeah.
Here we go. Loads of chat about this. They wanted to see the ratios being described for the method mark, and then a division. So that division was what they were looking for to get the second method mark, and then 4 for the accuracy mark. But because it was must show you working, I was like, oh wait, how many marks can I give him? Can I only give him one maybe? However, if you scroll down through here, the mark scheme continues on the next page. They clearly had a few issues marking this one for real.
And they give
alternative method, additional gut, another page. Flipping heck. Here we go. Special case. Answer 4 with no working or no incorrect working. Full marks. And I think that, so I wrote on your script, that's what the SC stands for.
Right, I got
Special case.
So I looked out.
Well,
I really need to improve my exam technique. There's so
I don't
many
think you
marks
do.
I'm losing.
I don't think you do. But you need to improve your GCSE exam technique if you were going to take GCSE again.
That's what I mean. I feel like a lot of, okay, circle theorems aside, every other mark I've lost or come close to losing is because, not because I haven't done anything wrong. Sorry, not because I've done anything wrong. It's
because you're working at a different standard of mathematics, I think.
Exactly. I'm doing it in a different way that isn't in any way...
This is a really nice discussion point for us to have and for students to have, I think, because proof questions are not black and white. They're human dependent, aren't they? And so if you were proving something to an academic from Oxford, I don't know, maybe you work with them from time to time, you wouldn't go through that division to prove it. You'd be like, you can see them, and they're like, yes, I saw it half an hour ago, stop wasting my time. Whereas in a GCSE paper, you do have to show it. And that's a really interesting thing for me. Maths is a fundamentally human exercise when it gets important, when you're trying to prove stuff. And it just means at GCSE level, the bits you have to demonstrate, you've got to go through more steps. And I don't think you should go through those steps anymore. I'd be worried if you had to in your work. That said, the exam would lose marks unless there's a special case. So I think when they did this and they were marking lots of works, I think they saw lots of good candidates probably do exactly what you did. And they were realising that this is ridiculous. We can't penalise good candidates because they clearly understand it. They'd felt like they just didn't need to show that division. So they put that special case in. And that's a sign the system is working, even if it does occasionally penalise you for these irritating things.
We have to give a power of 10, 2 to the 10, that's what he's got. And that was from figuring this other stuff out. That looks fine to me. That's the answer, 3 marks. Happy. Right, well, the next one was fine. The next one was powers of 2. This one,
I think
no
it was
matter how
fine.
you do it, was
2 to the power of 10. Like, unless like silly errors of subtraction were possible there, but neither of us made them, which is a relief.
24 was just plugging in 0, wasn't it, for X?
I did a little sketch, but yeah.
Doing this thinking, like originally I was thinking to myself, and I'm guessing this is where there might be a mistake for a candidate to make. Do you just sub in X equals 0, or do you want X minus 90 equals 0? That's what I was kind of...
And you know the answer,
for some reason, in my head. Of course, I know to plug in X equals 0, but I did have that moment of thinking about it, and I thought, oh, that's probably the common error that might happen in this question.
And I tried to solve it in 2 ways, just because I found myself getting in a bit of a twist, because I drew a sine graph.
And then you've got one in red and one in blue. Yeah,
and
so you've shifted it, haven't you?
Well, the red one's the shift, right? So I could see that I expected the answer to be -1, and I was like, let me just justify this, because I could have done without drawing that. I could have realised that when I put 0 in, I get -90, and so I've put that red mark on the left of my script at -90. So that was the other way. Either use the blue graph to think about it, or the red graph, and either way, I was like, right, it's got to be -1. I don't think I've made some stupid mistake. But for students, actually, drawing the graphs, I think, is way more useful than they think. Like, just having those graphs able to
100%.
sketch.
Yeah. Anything involving sine and cos, graphs are super helpful, I agree. Oh, this question. Gradient of OP is equal to 2, it reckons. Yes, good. Perpendicular and tangent. He did it the same as me, and I thought I was doing it wrong. Get in. With his negatives as well as half. Perfect. Now, I'm actually happy he got that one right, because that's how I did it. I didn't think it was the correct method. No, I was really happy with this one, because I thought that I was winging it with my product of gradients is -1. I was like, I don't think that's GCSE knowledge. Don't know how else to do it. I'm going with it. And then when I saw that that's how you did it, I was like, yes, thank God for that.
Did I do that? Yeah, we did it almost exactly the same way, didn't we?
Yeah.
And I wrote way too many words.
No, so yeah, no, you're right. You form your triangle. You know it's forming at a right angle because, again, circle theorem, the one that I know. But
this is the one we talked about earlier, right? Yeah. And I wrote, since tangent to circle is
useful...
perpendicular to radius at point of contact, way too much. Whatever.
The one useful circle theorem helps you, and then it's just the product of the gradients that are at right angles has to be -1. Yeah.
It's interesting that I think a lot of GCSE students know that fact as the perpendicular gradient is a negative reciprocal. which I think is a really bad way of remembering it. It's much neater to think they multiply to -1, and then you can do whatever you like with it. So I liked your style on that. I didn't write the words "I like your style," but I do like your style.
And then the second one, I kind of saw this one coming.
The length AB,
out the length. So that was just kind of a couple of bits of Pythagoras' theorem. You had to work out the equation first, didn't you?
The equation of the line,
the gradient. Got to work out the intersection. Well, we have a point on the line, and we know the gradient, so we can work out its equation, and then you can work out the Pythagoras theorem for the triangle.
Yeah, and I think in part A, you'd already got a bit carried away on your paper and started doing all the Pythagoras.
I figured out the radius, hadn't I?
Which I think is useful, right? You eventually need it. Oh, wait, no.
I'm not sure you do.
You did, because I remember thinking, am I going to dock Tom more marks for going down a rabbit hole he didn't need to go down? But then later on, you found your groove and realised that you didn't need
this one
all
took
those
me longer than I would have liked, to be honest. I think about this one. Yeah.
Well, actually, I don't know, just a little glimpse of your script on screen here. Like, it's really nicely laid out, this one, because I can sort of follow your thinking and like things are occurring to you. And then you've done all the radius calculations here just because you knew you could, and you're like, I want to do that. Or I probably
that was before I figured out that it was going to be the product was -1 things. Yeah.
And then you got the equation of the line, and I like the little sketch, and that's full marks, I think.
Good. Same for you. 26. The answer should be -24. Oh, I remember I did this. I spotted my own sign mistake on this question. Really annoyed. Anyway, right, 26, I made a sign error. I'm so annoyed. Yes. I noticed this when I was marking your script. I got the right answer, I just forgot the minus.
This was the classic slip. Like, negative signs errors happen to the best of us, don't they? And you just moved from one side of an equation to other and forgot the negative. That's it. I don't think there's much to say. Although, if I was your teacher and I was going to give advice, the same advice you've given to me before I sound too patronising, which is like, check your work, right? But the best way of doing that in this case is to have a diagram, because it's obvious then that the intercept is negative, and you would have noticed within microseconds that it's way too high.
So you didn't differentiate, which is how I did it. Because of course at GCSE you wouldn't technically know how to differentiate, even though it's a perfectly valid method. You better have given me the points for differentiation, Ben, because it's correct maths. Just saying. Ben, I guess, has done it the correct GCSE way. I'm assuming you didn't penalise me for differentiating.
No. Definitely not. It's a good method.
I said this in the video. I was like, I know this isn't how a GCSE student would do it, but I'm just going to do it because I've had enough at this point.
It's a good point. I forgot to pick up on that, because you're using A-level method. I mean, sledgehammer to crack a nut, I think, is a technical phrase for it, isn't it?
Yeah.
If you couldn't differentiate, how would you do it? Would you have a way?
I've now spotted how you do it. It's the shift, isn't it? So plus b moves x squared up by b, and plus a inside the squared moves it to the left by.
And it's nice that's also the completed square format. So it's now a big thing in GCSE to recognise that the completed square format contains information about a vertex, the turning point. And it's a really lovely piece of algebra that I love teaching at GCSE. But a lot of students it just passes them by, and if they have done differentiation, there's nothing wrong with that technique. So I was really glad to see that sledgehammer getting brought out.
Yeah, okay, good.
Interestingly, at this point, I finished my paper. I packed up. I was thanking the camera. I was like, I'm done, 50 minutes or something, clearly 26. And I think my script, because I was working on the actual paper on a PDF, it just wasn't loading very quick because there's just loads of graphics or something. So I scrolled down. I was like, it's all blank. I finished. And then 5 minutes later, I was like, whoops, there's question 27.
So
but on the script,
you could have possibly lost another 3.
I did, and it's on the recording. You can go and check.
Though, so I'm not going to take them off you because you would have still won. So it's
Well, so let's talk about the last question.
Exam technique is a lot better. This one took me a lot longer than I felt it should. I was able to figure
talk me through what you did.
Well, for me, I was like trying to figure out what's sine of 60 and tan of 30 by drawing graphs of sine and cos, and then obviously for tan, calculating sine of 30 over cos of 30.
Yeah.
So I just drew the graphs, and then but I'm guessing good GCSE students would know 30, 60, 45 for sine, cos, tan.
And that's a relatively recent upgrade in the last few years. They've explicitly said, whereas before A-level students were expected to know 30, 60, 45s, because they're super useful, right? They turn up all over the place, yeah?
Yeah.
They have put that in GCSE now, and I think it's a common discussion point that only higher students really need to know this. Like if they're doing the foundation tier, they wouldn't bother teaching it, which is sad because actually they are really useful. But it's worth sharing one thing that I remember being really pleased about is that when you can't remember what they are, all you have to do is draw a triangle, that equilateral triangle. It happens to be helpful if you draw the twos. And then because it's equilateral, you get a 60 and you get a 30. And then Pythagoras, I think, gets that as to be a root 3. I think it was in A-level exams when I was doing A-levels. I remember drawing these triangles in margins to make sure I'd remembered the angles right. And then sine 30 is 1 over 2 straight away. And the only other one you need is the 45-degree one. So if you do 1, 1, root 2, then you get the 45-degree ones for free. Yes. And so I'm often thinking of those, and by now they're kind of internalized, and I think of them in my head. But
I mean, I kind of did the same, but I drew the graph and then figured out, because, for example,
it's that nice point there.
Cos of 30 has to be the big number, because I know there's like root 3 in there, and I know there's like a root 2, and I know that I know roughly what the numbers are.
Yeah, you just got to remember which way round they go.
Flat at the top and then decreases faster. You know that cos of 30 is the root 3 over 2 one, and then from there I could kind of figure out stuff.
But it's an example of a GCSE question which was harder for you than it would be for a GCSE student who has learned the things that they're ready to use. Yeah. But you nailed it. You got full marks, and I hope I did too. 60 degrees. Oh yeah,
you did.
It did. Yeah. It mattered that they said it was acute because if you were trying to solve cos x equals a half, there were some other answers to find.
Yes.
But then so
yeah.
Although I
noticed that you circled that, and you also wrote 300, but then you only for your answer wrote 60 because I guess you'd. Making sure you had all the cases.
At that point, I noticed that they'd said acute for a reason. I was like, I'm going to try and get bonus marks. No.
Non-existent bonus marks.
To be honest, at this point, I was just relieved I'd remembered that this question existed, which is why I've circled end of questions and like, oh, thank God I noticed that finally.
So that is a very, very good 78 out of 80. Well done, Ben. I'm pretty sure you beat me because I couldn't do that circle theorem question. And I know I got another one wrong, so I reckon I've got about 75 or 76, and Ben's got 78. There's no way I've beaten 78, so I'm already now going to accept graciously my defeat. Very well done, Ben. I'm clapping you. As you can tell, I'm really excited that you beat me, so well done. Well done.
So yeah, that's it. We made it to the end. Now, did we add them up correctly?
I think so. No, I'm just thinking of what I dropped. So I dropped the feathering mark.
Yes.
For the graph, I dropped the mark for something else that was a silly mistake. That was a GCSE.
So feathering on question 10.
Yeah.
Or the double line. Then there was a single mark on the not simplifying fully the 4 over 6.
Yeah, of course. 4/6 being 2/3. Yeah, that's fine. Yeah.
And again, like it's a mark that circle. No other shame should be attached. It's just one of those things that good mathematicians do. That was 2 marks down. So then you lost 4 marks on question 20.
I thought I was going to lose all 5. I literally thought I was going to lose all 5 on that one.
Luckily, you remembered what isosceles triangles were, and you got some credit for it.
And then the sign error. Is
that right?
Happy.
4, 5, 6. That's 7 marks. That is right, isn't it? Yeah.
Yes. And your 2 were the
which one? The
approximation of the prism. You forgot the square root thing. You did like a muddled
calculation.
X. And then the subtraction. You subtracted 9 instead of 7 on the difference of 2 squares.
I think both of us are fine. So the one lesson.
Well, me apart from circle theorems, right? If you take out me not knowing circle theorems, we were basically identical.
Yeah, because that was 4 marks, right? And you'd have got 77. And it was just little slips. It was a sign error.
I made one silly error.
Simplification error and a controversial feathering error. Yes.
Yeah.
Which I'm inclined to ignore, to be honest. If we cut that graph sketching out, if you'd done it on the paper, that wouldn't have happened. I think.
I probably would have still feathered it. I didn't realize. I honestly just, as I said, it's a habit I have when I draw a graph. I always do it several times. Like in any of my other YouTube videos when I'm drawing graphs, I do it like that. So I think I probably
to make the shape look right. Yeah, I think
I still would have done it.
Interesting that you didn't do it on the cumulative frequency, but I don't know, whatever. Yes. However it pans out, we're now seeing what they penalise and what they're rewarding at GCSE. Yeah. And nothing, which is much to my relief, nothing that we did, I think, is sort of in direct contradiction to what the GCSE exam scripts wanted the students to do, which is good.
I think the main takeaway, if I could sum it up, I think the main takeaway is neither of us really did any wrong maths. Or there was
agreed.
A minimal amount of incorrect maths. One or
What's
two
interesting is that I
very,
did
very
wrong
silly errors.
calculation, right? So I didn't do wrong maths, I did wrong calculation. And I feel like in my head
Yes.
that's different. Calculation,
Sorry,
arithmetic. Yeah.
Apologies. Yeah, none of us did, apart from me not knowing circle theorems, none of us did any wrong maths. We just
wrong
did
thinking.
some calculation
Yeah.
areas, calculation errors crept in, which happens to everybody. They're all over my A-level exams as well. So I knew it was going to happen. It's the pressure of recording what you're doing. It's the
Which is the same as the pressure of
through.
doing an exam as well, right? I mean, the pressure's real, and it will be true for everyone doing the exam. But it's nice to know that the examiner's notes recognise all those things, and they award marks where they can. And so exams are pretty fair, and they have to be that black and white in their mark schemes in order to make it consistent. And it's frustrating when you get a special case and you're like, but actually, from my experience, I did one season of actually marking papers for GCSE and A-level.
I was going to ask about this because I could tell you knew how to mark exams. I didn't have a clue.
It was well over 10 years ago, so don't assume I know anything. But it was a sobering experience because actually the main combat you have as an examiner is boredom. Like you're marking again and again, but every script you're looking at really matters to one person. And so you getting bored and like, whatever, 0 marks. It's not okay. And like that pressure really, really starts to play on you, which is why I'm really glad the examiner's reports, they're really full. They're even more full than what we use to mark it because they have meetings all the time. Special cases get handed to a team leader and then taken up the chain if they need to. It is done well, but actually I think both of us have been reminded now what maybe a difficult job to do it well is.
Oh God, yeah.
and they rely on teachers volunteering around the country. They're not volunteering, they're getting paid, but there's like an army of teachers who are busy people saying, I'm also going to mark some exam scripts, and thank goodness they do.
We are very, very, very appreciative of the efforts from all teachers in everything they do.
Well, yes.
Genuinely. Hopefully they know this from us, but we love teachers and everything that they do.
So the conclusion of our not a competition is that we both did fine, and that's a good outcome, right? Yeah.
I love how this is coming from the person who won the not competition. It's fine. We're going to do a rematch. I don't know what it's going to be yet, but we are absolutely. I'm saying it now, right? It's like all these boxing fights that have been happening at the moment. You know that contract that you signed beforehand saying that the loser's allowed to invoke a rematch clause. The rematch clause is being invoked, and we are. A
rematch on a non-competition, is that what you're trying to invoke?
Yeah.
I mean, every video title we've published about this has said this is not a competition. But I am up for doing something like it again, whether it's another GCSE, another A-level, or something like. I'm just going to float it out there, like the UK Maths Trust Challenge things.
Those ones,
that would scare me.
Could be quite fun. They would be terrifying.
But
like puzzle thinking.
More of the same sometime.
Something.
I'm well up
we'll
for it.
We'll figure something out. But no, thank you so much, Ben, for joining in.
My pleasure.
My ridiculousness of doing exams. It's been really good fun. It's been great to have somebody else to share the experience with, and I really appreciate all your insights, in particular with the marking, because as I said, even with the mark scheme, wasn't sure exactly how it all works. So it was really nice to hear your input onto how, as someone who's much more familiar with marking and GCSEs, to know how to actually interpret that and to give us those insights into how they actually check these things.
As long as you don't take my word as gospel, because there's plenty of times I'm making it up as well. But yeah, and it's been really nice to have someone, like, even if you mark your own script, like, I know what I was thinking. And so watching someone else, a good mathematician, do it, trying to get in their head, is a very good experience to remind myself what marking feels like. Yeah. So thanks for that. Thanks for including me.
You're welcome. I've learned a lot. I hope everyone watching has learned a lot. Please do remember to subscribe to my channel if you've enjoyed this video. Check out Ben's channel, which is Sparks Maths. You'll see, if you haven't already, you can watch him do the whole paper. Now that you know how he did, you can see how it should have been done if you happen to have only watched mine. And you'll hopefully see both of us around on some more number file videos very soon as well. So again, thank you everyone for watching, and I'll see you all soon.
Thanks, bye.